In this video, we will look at 3 high-speed taxi runs. For these tests, both engines have been modified. However, each engine has received a slightly differently configured modification. The purpose of this test is to show us which modification configuration is the best fit for our engine type, producing the most thrust for a set power setting or N1 percentage. The first test starts off with both engines set at a takeoff setting of 90.0% N1. When the brakes are released, we then see that the aircraft veers to the right, quite significantly, indicating that the left engine is producing more thrust than the right engine. We also see a difference in fuel flow during this run, with the left engine showing a lower fuel flow than the right engine, even though the left engine is producing more thrust. For the second test, we decided to try and match the thrust of both engines, aiming for equal takeoff thrust. We decided on a 2% N1 reduction for the left engine, down to 88.0% N1, with the right engine still set at 90.1% N1. As is visible, even with this reduction, the aircraft is still veering to the right, albeit less pronounced. In response, thrust of the left engine is immediately reduced further until the aircraft is tracking straight down the runway with 86.0% N1 on the left engine and 90.4% N1 on the right engine. For the third test, we decided to make a run in the opposite direction to evaluate the effect on our tracking of the minimal wind condition. We again set the left engine at 88.0% N1, and the right engine is now set at 90.2% N1. You can now see the aircraft tracking straight down the runway, giving us a good indication that the thrust is matched for the given conditions on this run. All in all, without wind, an N1 of 87% on the left engine would have produced the same result. Now let's have a look at the difference in fuel flows between both engines. A regular unmodified engine burns more than 1,700 pounds of fuel per hour at a higher N1 of 97.3% for the conditions on this day. Our modified engines, however, are producing about the same thrust as the regular engine, but at reduced N1 settings and while burning significantly less fuel at 1,214 and 1,345 pounds per hour. This is 29.2% and 21.6% less. These tests show us that the left engine was more efficient by a margin, producing more thrust while burning less fuel, bringing us one step closer to the ideal configuration for the model of engine that we're testing with.